Let's move on with the instruction. You'll notice that there are number of files already auto-generated via Hardhat sample project tool. We will be replacing all of them starting with greater.sol contract. So we don't have creator.sol, instead we have log.sol. So I have installed all the latest version, so you can also install the latest version if you like. So I got a log.sol instead of greater.sol. Now let's rename it with the buy me a coffee.sol. Now let's copy the code. Now let's copy it line by line. First we have to find the compiler version. Now let's copy a contract name. Here we have an event, and here we have a struct. Now we have now copy all. Okay. Then we have added our contract deployer. This is memo struct. Then we have list of all memo received from coffee purchase. Then there is the constructor where we are setting the message of sender, the one who will going to deploy this contract. The address, fetch all the stored memos that will going to return the all the memos. Now let's uh, see the function buy a coffee for owner. Send an Ethereum tip and leave the memo name of the coffee purchaser, message a nice message from the purchaser. So there it is. It have a required that everyone should send at least some amount rather than zero. So user have to send any amount, uh, any Ethereum, not zero Ethereum. User can't send zero Ethereum. Then we have uh, pushing it in the array, the struct. Here it is. What it takes is take the message sender, the one who is sending the memo, the timestamp, the current Unix timestamp on which user is sending a memo, the name, the message. Now there is a emit code. Here we have defined the event, and we are triggering this event by using this command emit. So it will going to return message sender, block timestamp, name, message. So it will be useful when we are going to create a front end app. We will going to get this event in our front end application. So we will get these fields, so we can display them at the front end for better user experience. Now there's the withdraw tips. Only owner can withdraw this balance. So I think there might be a missing of a condition, but it is said that owner will get the balance of that smart contract. Someone sent money, someone sent a ether, it will be stored in a smart contract, and from a smart contract, owner of this contract will withdraw this money to their own account, the own wallet, the same wallet through which that user have deployed as a smart contract. So now let's move on. Take some time to read through a contract comment and see if you gather what's going on. Let's just highlight here. Here it is. Paper letter is useful later when you want to withdraw the tip collected by the contract. The buy coffee is most important function on the contract except to string name and message, and also accept IA of ether due to the payable modifier. It uses name and message input to create a memo struct that is stored on a blockchain. Ethers call the buy coffee function. They must submit some ether due to the required message.value statement. The ether is then held on the contract balance until it's withdrawn. The memos array holds all the memo structures generated from the coffee purchase. New memo log event are emitted every time a coffee is purchased. This allows us to listen a new coffee purchase from our front-end website. Withdraw tips is a function that anyone can call but only ever send money to the original deployer of the contract. Address resource balance fetches ether stored on the contract. A owner.send is the syntax of creating a send transaction with ether. The require statement that traps everything and they ensure that if there are any issues, the transaction is reverted and nothing is lost. That's how we get require owner.send address of balance. Armed with the smart contract code, we can now write a script to test our logic. So here it is. We have write and seen the smart contract for buy a coffee. Now let's move on to create a buy-coffee.js script to test your contract.